Hi guys, I thought I'd just go through WaterCycle and make sure that all those main ideas are in your heads, because I basically missed you guys doing this. So it's me making sure everyone's up to date. Just the main terms. So water's actually really interesting stuff. Water can be either solid, liquid or gas on the earth without really much energy required. So it doesn't take much to change it from sort of liquid back to ice or liquid up to gas, which makes it really useful for supporting life. So when you're looking for life on other planets, they always look for water. So really interesting chemical that supports life on our planet, and we presume it supports life on other planets. However, it can obviously be solid, liquid and gas, as we discussed. So here's this lovely lattice of the water molecules in a piece of ice. And interestingly enough, they're further apart than they are when they're liquid, which is unusual for a solid. They're normally much more closely packed together. This means that ice floats on top of water, which means life in streams which freeze over can continue because underneath there's water, which is pretty good. And of course, classic thing with water vapor, that they separate out and they move around rather fast, lots of energy in them. So this means we've got a cycle that can be used on the planet to keep water available for all living things. So the first thing we need to do is evaporate the water, and so from oceans and lakes and puddles and wherever we spill some water, it will evaporate. So the sun's energy will cause the water molecules to become hot, move apart, and start to rise because they're getting lighter, because there's only hydrogen and two oxygen atoms. It's a very small molecule. I know we haven't talked too much about molecules, but that's what we call a molecule. This is a molecule of water. H2, there's two H's, and the O. Very small, very light. So as the sun heats them, the salt gets left behind, and the water enters the sky and keeps traveling up into our atmosphere. Really good because you got rid of the salt. Most things don't like salty water. Really useful. So another form of evaporation is called transpiration. So in this case, all that water that's infiltrated the soil is taken up by the plant roots, and it moves up through things called xylem, these tubes that work only in one direction. And the water flows up the xylem into the leaves, and on the leaf surface, it actually leaves the leaf through a thing called a stomata, a little hole in the leaf, and then it's evaporated off. And again, so it becomes atmospheric steam rather than water, but it moves through the plant, taking lots of really good nutrients out of the soil up into the plant for its use. And then obviously it needs water as well. Then all that water up in the atmosphere is, I'm in the way there, aren't I? Let's get me out of the way a minute. All that water up in the atmosphere starts to condense because it gets cold. And as it gets cold, of course, it's losing energy. It needed energy to get small enough to get up there. Now it's going to get lose that energy, become water again, and gets heavy. So essentially, we have a thing called the adiabatic lapse rate, and roughly 1 degree Celsius, it cools 1 degree Celsius every 100 meters you go up. So if you have a mountain that's a kilometer high, then the temperature at the top of that mountain is 10 degrees less than it was at the bottom of the mountain, roughly 9.7, 9.8 something. So obviously, if the water's gone up a kilometre into the sky, it's also now 10 degrees cooler. If it goes up 2 kilometres in the sky, or 3 kilometres, then you're losing 20 degrees, 30 degrees. So it gets much colder, much faster, and we form these droplets. And once they condense, they often form around dust particles and things before they fall. So as they condense, they start to get too heavy. And of course, we get, why didn't it move? Precipitation. I was going to be really classic then. I was going to do a really good segue. Anyway, so precipitation essentially falls as either rain, snow, sleet, hail, and even fog is a form of precipitation. Fog's often a really low-lying cloud that's, of course, you're walking through water, basically. So the water condenses around these little dust particles and things, forms bigger droplets, and becomes too heavy. So it's just too heavy to stay up there, and it falls. So sometimes you see a really nice big rain cloud heading across the bay towards us here in Mount Eliza, and as it hits the mountain of Mount Eliza, it's only 50 or so meters, but it's enough to cool it to cause rain. And often you get more rain in Baxter at school than I get at home in Mount Eliza, because the rain then falls on the other side of Mount Eliza. So often there's more rain, and it's often cooler too at school than it is at home. That's just because this adiabatic lapse rate causing the stuff to get condensed as it rises up over the mountain. Not as much of a mountain. And of course it's the ground, and as we saw recently with all that lovely drought-breaking rain, we've had what's called the autumn break, and we've had some good rain this last week. That water goes back into the soil. And although we've got a creek and a series of ponds that run through the wildlife reserve and then the school, the soil has been soaking up so much of it because it's so dry that the ponds are only just starting to fill and the creeks are only just starting to run. And yet we've had about 50 or more mils of rain in a 10-day period. But the soil was so dry, most of it has infiltrated the soil. It'll slowly work its way into the stream as it comes downhill. It's going to work by gravity, obviously, towards the lowest point. So we'll end up in the stream, we'll start seeing the creek run, and those ponds will start to fill, and the frogs will start to get very excited. In fact, you're hearing frogs calling now, which is lovely. And then it runs off. So the runoff collects in the streams and heads back out to ocean, and we're back where we started. This wonderful cycle of water that supports life on the planet. So the evaporation of the ocean and the forests and lakes and things, condensation in the atmosphere, as it heads inland and gets forced higher and higher, it starts to precipitate, infiltrates the soil, feeds the plants and trees and everything else, and works its way back in to feed the streams and ends up back out in the ocean. That's one really important cycle, the water cycle. There are a number of other cycles, of course, too. The carbon cycle, which we're mucking around with. We're getting far too much carbon up in this part of the cycle and not of it trapped down here in the oceans and in the soil and plants, which is causing a new problem for us all. Nitrogen cycles, all those sort of things that we need in our daily life, all have their own cycles through the natural world, through the water, the hydrosphere, through the atmosphere, and through the land, the lithosphere. And that all supports what we call the biosphere, the living things. But that's for another day. I've gone too far again. And I'm all done. See you in class.